Hello everybody. Since we have just a limited time to discuss a huge surface area, the Rx surface area, we have no time to discuss all the intimate details about Rx. So here what we're doing now is we're going to give you a little bit of a potpourri of kind of small things concerning Rx that might be interesting. But again, I would really advise you, if you want to learn more about Rx more in depth, that you look at the Rx wiki or the ReactiveX.io site, where you can find a lot more information. All right, let's look at this example here. In the earthquakes example, we used this constructor, the observable.from, that took a future when we were doing the reverse geocoding. So that the reverse geocoding returned a future, and we wanted to turn that into an observable. And I just kind of used that without, thinking too much or saying too much about it. But I think it's interesting to see how we can implement that. And we're going to implement that using an async subject, which I said was very much like a future, because it had only one value, or very much like a promise, I should say, because I can set it and it has only one value. So here's the code. We're using the apply constructor for here on observables, with overloading it with a future, and we get back an observable. Since we are, in this case, we want to remember the last value of our stream, what we're going to do is we're going to create an async subject, and then when the future is complete, what we're going to do is we're going to look at the two cases. If the future completes with an error, we're going to complete the async subject with an error. If the future completes with success, we're going to call onNext on the subject and then immediately complete it. Now, what this gives us is the behavior that we want from a future, is that it only executes once, right? When you kind of pass a callback, the complete callback, the incomplete callback to a future, if you pass it multiple times, the underlying computation is run only once. And that's the behavior that we get here by using the async subject. So if you subscribe to this subject, it will always kind of give you the last value without rerunning the computation. So it's a subtle, side effects are always subtle. You have to think hard about them to make sure that they don't get duplicated or that things get run more than once. So this code here is quite subtle, and therefore, you shouldn't write these things yourself. The Rx library has most of these operators where all the details are taken care of for you, such that you don't have to worry about that. Now, the other thing, if we look at the class try of t, what we see is that really the two cases of success and failure were represented by data structures. Okay, and if you remember one of the very, very first lectures where I said, oh, but if you get a function that takes a try of t as a parameter, the first thing you're going to do is you're going to pattern match on these two cases, and you're going to use two functions, one that takes a t to unit, say, and the other one that takes a throwable to unit. So instead of materializing the try of t into a data structure and then destructing it using pattern matching, you might as well immediately pass the two functions. But of course, maybe in Rx, you want to do the same as try of t. You want to materialize the notifications. So instead of passing 3 callbacks, you might want to get an observable, just like you want to get a future of try. You want to get an observable of something that represents, onNext, onError, and onCompleted. And for that, we have the idea of a notification. So a notification is either onNext, onError, or onCompleted. So that's a data structure that represents the signal that's sent on an observable. And there's a function here, materialize, that takes an observable of t and turns it into an observable of notification of t. All right? And now when you subscribe to this thing, your subscription has to pass a function from notification of t to unit, just as what you get with a future. Okay? So you can always kind of move between these two things. So pattern matching or passing the function separately, it's all the same thing. It's whatever you feel most comfortable with. Okay, so here's a marble diagram for materialize. We materialize this thing. We get 2 on next, followed by an on complete. And then the funny thing is then that stream completes itself. So there's 2 on completes because there's the on complete that's materialized, but now this materialized stream also completes. Okay, now the other thing that we had with futures was that we could block. And remember, I said that was really bad. You should never block, because once you block, all the asynchrony basically evaporates. The same is true for observables. Once you are in observable land, everything should stream. You should never block. But sometimes, for whatever reason, probably you want to do debugging or you want to do a little demo script, you want to block. And for that, we have an operator called toBlocking. And really it should be called toBlocking is unsafe. Make sure that you know what you're doing if you're using this operator, or something kind of ridiculous like that. But we just called it toBlocking. And what this returns is a blocking observable that has certain kind of convenience methods defined on it. And this kind of just blocks until the observable is done. And here's an example. So we kind of do interval take 5. We say toBlocking, and then we can do a list, and then we can print the list. Or we can say toBlocking and make sure that's a single value, and if it's not one element, it will throw. All right? But again, you should really not be using toBlocking except for small demo programs. So you can look in the IntelliSense when you do toBlocking what methods there are, but I really recommend against using this. Once you're in a streaming asynchronous world, you should never block in the first place. Okay, the next thing is some of the higher order operators that are available on iterable as well. And you might have questioned where's reduce, where's fold left and fold right. The thing is, again, if you're in an asynchronous world, reducing a value to a scalar type doesn't make a lot of sense. So for example, if I want to reduce a stream to a single value, well, this stream might be infinite, or you want to kind of, it's like you have to wait for a long time until you get the resulting value. And so you usually don't use reduce a lot. And another difference is that just like in SQL, when you do a reduction on a table, you get back a table with a single row. And the same here. When in Rx, you reduce a stream to a single value, you don't get a scalar, you get an observable that has that single value. All right? Whereas with iterable, when you reduce it, you will get a scalar. But here in this case, we say, once you're in the observable monad, there's no way to escape except via toBlocking, and then you make it explicit that you're doing something bad and something dangerous. As the last example, I want to show you how to create an observable from an iterable. All right, and then of course you can also go from an observable to an iterable with toBlocking, but I want to kind of go the other way now. Okay, so but in some sense you can go in both directions. And here what we do is we're using the apply method that takes a subscriber and returns unit. And what we typically do here is we're just going to kind of take the iterable, we're for eaching over it, and as long as we're not unsubscribed, we're going to call on next. When we're done, we call on completed. Now this can lead to problems, because imagine that, you know, I subscribe to this running on a different thread. Now the consumer might be much slower than the producer, okay? And in that case, it means that we have to do unlimited buffering. For that, RX has a notion of back pressure. Again, that's outside the scope of this course, but in the jam sessions, we will have a demo to show you how easy it is to add back pressure support in these cases. All right, and you can also go to the RX wiki, and there's a whole section that explains all the strategies that you can use to do back pressure. So that's the case where the consumer and the producer are decoupled and don't run at the same speed, and you want to prevent buildup of unlimited internal buffers. All right, thanks. That was already, again, the end of the RX potpourri, and see you next week.